Let us move on to the second kind of problems. That's a type 2 case. So as we said, in the type 2, I'll be considering a circuit with at least one independent source and dependent sources. So this is a question here. So here the question is, so there's a 4 ohm resistance, the Ix here, a plus minus a 20 volt source, and this is a 5 ampere current source, a 2 ohm resistance, and here we have controlled source plus minus twice Ix. Yes, the question is to find Ix, the value of Ix, find the value of Ix using superposition theorem. So we need to find out what is Ix here. Find value of Ix using SPT. Superposition theorem. Okay, now, so you just observe the network here. In a given network, you can identify there are total 3 sources which are given here. In that, 2 of them are the active sources. One is your 20 volt voltage source and the other one is a 5 ampere current source. They are the active or independent sources. And the other one is, which you are represented in a diamond form, that is a dependent source. It is a dependent source. So this is a dependent source here. This is a dependent source, and these 2 are the independent sources. Guys, in a network, the significance of this kind of dependent source, or I can say a dependent source, are valid only in presence of an active sources. So while you doing with an SPT, you just go with a normal procedure by considering one source at a time, but you have to consider only the active sources which are present. So now you identify here, we have 2 active sources. One is 20 volt source and the second one is a 5 ampere current source, and go with the as usual normal procedure, by considering one source acting at a time, find out what is the value of Ix. So if I write, by SPT, if I compute what is the net current Ix here, I'll just represent it is Ix dash plus Ix double dash. So here I will call the Ix dash is a response due to 20 volt source acting alone, and Ix double dash is a response due to a 5 ampere source acting alone. So now find out the value of Ix dash and Ix double dash in presence of 20 volt acting at a time and the 5 ampere current source acting at a time. So now consider the step 1. So don't worry about the other dependent source here, So now I'll consider in the step 1 a 20 volt source acting alone. So now when I consider 20 volt source acting alone, so this is a resistor, a 4 ohm, and the voltage value, what is the voltage value? It is a 20 volt, and this is a 5 ampere current source which I have made as an open circuit because we are considering only one source acting at a time, and we have our dependent source. So you write as it is, the dependent source. So it is a dependent voltage source. So you can write whose value is, it is 2Ix. So whose value is at 2Ix. So you can write it is 2 times Ix. Now observe here that controlling variable is, it is a current flows through your 4 ohm resistance. This was your Ix represented. So now I'll call, since it is, we are calculating Ix in presence of a 20 volt source acting alone, I just change the notation, that is Ix is same as now it's Ix dash, because it is a part of the solution. So I represent it as a Ix dash. In that case, this also will become an Ix dash. Ix dash. So this is a, after when you consider a 20 volt source acting alone, so this is a simplified network. Now here you can find what is the value of Ix here. What is the value of Ix? This resistance value is 2 ohm. So now you can just observe this network. It is a one single loop network here. If you apply KVL, you will easily obtain what is Ix dash. So now I'll apply KVL to this loop. So if this is the current flows through this loop, it is an Ix means, so this is the polarities plus minus. So now you apply KVL to the loop, KVL to the loop. So a rise in potential 20, a plus minus the polarity for this resistor, because the current flowing in this end to this end to this end means it will be always from higher potential to lower potential. So that's why it is starting point is plus and the other end point it is minus. So plus to minus, it's a drop, minus 4 resistor into a current value, it is Ix dash. Again here a plus to minus, it is a drop, minus the resistor value is 2 and the current flows through the same resistor, it is with the same loop. Since it's the same current flows, it is your Ix dash. And this is an voltage source here, it's a dependent voltage source whose value it is 2 times the Ix dash, and that Ix dash is a controlling variable which is defined, it's a current flows through a 4 ohm resistance branch. So now if you write the voltage value, a plus to minus, it is a drop and the value of the voltage is twice the Ix dash, which is equal to 0. Now this is a single equation with only one unknown, that's Ix dash. So simplify for Ix, so you get Ix dash is, it is 20 divided by 8, you will get 20 divided by 8, which is same as a 2.5 ampere. So that's the value of Ix dash when you consider, only a 20 volt source acting alone. So in a step 2, that's a part of the solution, in a step 2. So in step 2, now we have another source. The source value is a 5 ampere current source. So now you consider 5 ampere current source acting alone. So what is the equivalent network here is, so this is your a 4 ohm resistance. The response we called it is your Ix double dash, and this voltage source you make it short. Why short circuit? Because if you make a voltage source to be 0 means a voltage across a short circuit is 0. That's why you are making that voltage source to be on short circuit, and you have your current source a 5 ampere, and the other part of the circuit is it's a 2 ohm resistance along with in series with your dependent source, a plus minus whose value is, since it is 2 Ix, so now I have changed the variable to Ix double dash, then this also will become Ix double dash. So this is a simplified network when I consider only a 5 ampere current source acting alone. So your main aim is to find out what is Ix double dash. So how to find out Ix double dash, guys? Suppose if I write a KCL, consider here we have two nodes. One I will consider is a reference node here. So now if you apply KVL, say I will consider this is a node X, I will consider say node A. So the voltage across this will be VA. So we are interested in what is Ix double dash. So for as per this notation, if I write Ix double dash, so you can write Ix double dash is, so we wanted the current in this direction, So if this is the potential means, so you can write it is minus VA divided by the resistance, here it is 4. So this is the value of Ix double dash. So first let us find out what is VA value. So to find out VA value, apply KCL. So all living currents. So apply KCL at node A. So the living current in a 4 ohm resistance branch is VA divided by 4 plus living current in a 2 ampere current source, a 2 ohm current source here is, rise in potential is VA. Again we have another voltage source, that's a controlled source, whose value is 2 times of Ix double dash. So you can write plus to minus, it is a drop, minus 2 Ix double dash divided by the resistance along this path is, it is 2. Resistance along that path is 2. So that's the current flows through a 2 ohm resistance this branch, and here the current, living current I wanted, actually it is a current entering. So you can write the living current is minus 5, which is equal to 0. So now observe here, it's a single equation but 2 unknowns. One is VA and another one is your Ix double dash. So but you observe here, your Ix double dash you can eliminate. So from the network you observe, you can write your Ix double dash is minus VA divided by 4. Ix double dash is minus VA by 4. You can use this equation here, So you will get, everything in terms of VA. So if I write that, so this equation will become now, so you can write it is a 4 inverse VA plus it is 2 inverse into VA minus 2 into your Ix double dash, you can write minus 4 inverse into VA minus 4 inverse into VA minus 5, which is equal to 0. So simplify this equation for unknown VA. Simplify this equation for unknown VA. Sorry, the VA is, you will get the value of VA is 5 volts. You get the value of VA is 5 volts, and if you do the division, so you will get the value of Ix is, now it is minus 5 divided by 4. So you can write the value of Ix double dash is, it is minus 5 by 4, it is minus 1.25 amperes. Minus 1.25 amperes, again by SPT. So find out what is the net result here. By SPT you write the by SPT. So by SPT you can write superposition theorem. You can write the resultant Ix is, it is Ix plus Ix dash plus Ix double dash. So this Ix dash we got, it's a 2.5 ampere plus, and the Ix double dash is, we obtained it is minus 1.25. So the resultant value of Ix is, it is 2.5 minus 1.25, you will get 1.25 ampere. So this is the value of Ix what we get from that network using an SPT. Hope this clear. Okay, dear students, I think in the last session we have discussed the concept of superposition theorem, and along with a few problems I have discussed. So now in this session I am going to discuss the all possible cases of the problems which arises from superposition theorem. I will be discussing in this session. So basically, when you look at the problems which are asked in superposition theorem, from the concept of superposition theorem, we have three kind of problems which comes in the examination. So one is if I consider the circuit, so the type 1 problems is the circuit consisting of only independent sources. The second category is the circuit consisting of at least one independent source, at least one, even can be more than one independent source, at least one independent source and dependent sources. And the third category is circuit consisting of all dependent sources. This is a type 3. See, in case of type 3 case, when the circuit having all the dependent sources, and all these dependent sources have the significance only in presence of at least one active source. If it is present in the network, this dependent sources will have the significance. Otherwise, if the circuit completely consisting of, say for example, I'll just see the network, I'll just consider a network with only a dependent sources. Say 2I is the current source value. See this kind of network, guys, say 2 ohm, at 3 ohm and 1 ohm here and 4 ohm. This is a controlled source, it is a current source. The controlling variable is I here. I'll just represent that controlling variable with some other branch, it is your I. Now if the circuit consisting of this kind of sources, so I'll just take one more source here just for representation. Say let me consider one more dependent source. See, this is the voltage source whose value I will consider, say 3 V0, and I am considering the controlled variable whose voltage value is, say, a voltage across your 2 ohm resistance here. So whenever circuit consisting of this kind of sources, that is all dependent sources, the response in any of the branch, that could be voltage or a current, whose value will be 0, So that is the case 3 kind of problems. So now I'll just go with the case 1, the type 1 category problems. I think last class I have solved only few problems. So I'll take up one more question from this category, then I'll move on to the case 2, that is a type 2 questions. So that is a network consisting of both dependent and independent sources. So now this is a question. So find out by SPT what is the current flows through a load resistance of RL, it's a 5 ohm resistor here, and this is a 4 ohm, and this is your 2 ohm resistance, and one more 2 ohm here, and the source at 20 volt, and there is a load resistance which is given here. This is what your RL, The value of RL, it is given, it is 7.5 ohm. 7.5 ohm. The question is find out what is the current flows through a load resistance RL using SPT. This is what we need to find out using SPT. Hope the question is clear here. So now if at all you wanted to solve using an SPT, so we know the response in any particular branch, that could be in a voltage or a current, the total response in any particular branch is nothing but a algebraic sum of an individual responses by considering one source at a time. Now just observe this particular network here. So we have two active sources which are present. One is a 10 ampere current source and other one is a 20 volt voltage source. Now you can consider in the step 1. So I'll just write down, say the total response your IL is, which is equal to, I will consider it is say IL dash plus IL double dash. Means I am just considering the IL dash is a load current when only a 10 ampere current source acting alone by making 20 volt to be 0, and IL double dash is, it's a response, it's a current flows through a load resistance RL when only a 20 volt voltage source acting alone and by making the 10 ampere current source to be 0. So now let us find out what is the individual responses by considering one source acting at a time. So now I'll just write down the same circuit here, the same circuit by making the voltage source to be 0, the voltage source, I'm just considering now the case 1, the step 1, I'm considering, so now 10 ampere current source acting alone. 10 ampere current source acting alone. In that case, so what is your equivalent network here? So we have your 10 ampere current source here and one resistor of 5 ohm, and the another resistor here, it is a 4 ohm, and the another resistance 2 ohm, and here we have another resistance 2 ohm, and this voltage source we are making 0 means considering to be a short circuit. So all voltage sources to be considered to be a short circuit, so that you can consider it is a 0 volt. So now the load resistance here, you have your load resistance, that's a RL, which is 7.5 ohm. So we need to find out what is this current. We need to find out what is this current IL dash I'll call. So now just look at the network, guys. So when you look at this network, here we have a 2 ohm resistance and 2 ohm resistance. These two are in parallel, that you can observe, a 2 ohm resistance and 2 ohm, they are in parallel. So this combination gives a 1 ohm equivalent resistance, a 2 ohm parallel with 2 ohm results, a 1 ohm, and that 1 ohm is in series with your 4 ohm resistance. So total you will get a 5 ohm resistance. So I'll write equivalent network now. So we have your 10 ampere current source and a 5 ohm resistance, and again here we have a 4 plus 1, this is your 4 ohm and this is your 1 ohm resistance, and we have another resistance of your load resistance, your RL. So we are interested to find out what is your IL dash here. So this is the scenario. So now to find out what is IL here, so I can go with KCL or KVL concept. It's a simple network. So you can use, if I'm finding what is the node voltage, So here I'm just representing, this is a node A and this is a node B and it is a common node. a reference node, it is on ground point. So if I write what is the KVL at this KCL at a node A, KCL at a node A. So you can write an equation here, the current, leaving current of this branch, leaving current of this branch and leaving current of this branch. You can write it is VA divided by the current flows through 5 ohm resistance is VA by 5 plus the current flows through the load resistance is your VA divided by it is 7.5 plus a current flows through at this particular branch. You can observe the series resistance, equivalent resistance is 4 plus 1, it is 5 ohm. So you can write it is VA divided by 5, and here actually we wanted a leaving current. So since the current is entering the source to a node here, so you can write it is a minus 10 ampere. So minus 10, which is equal to 0. So now you can, with this single equation, try to solve for VA. So if I solve for VA, it is calculate. So you get VA is 18.75 volts, but we need to find out what is a current flows through a load resistance IL. So you can write that IL dash is, it is the voltage across this load resistance is same as your voltage VA here. This is a voltage across this resistance is same as your VA. So you can write the current value is, it is VA divided by your RL, or you can write which is equal to, so it is 18.75 divided by 7.5. So you can write what is IL dash divided by it is 7.5. So you get a 2.5 ampere. The value of IL dash is, it's 2.5 ampere. So that's a solution from the step 1. So this is a part of the solution here. That is, when I consider only a 10 ampere current source, the response what we got here, it is the IL dash is a 2.5 ampere. So hope this part is clear. Now let us move on to the next case. That's a step 2. So the step 2 is, now consider the other source. So what is the other source here? It is a 20 volt voltage source. Now considering a 20 volt voltage source acting alone. So now make other current source. What is the other source here? It is a 10 ampere current source. You make it 0. So make it 0 means you consider it is an open circuit. So now this is the current source. Make it as an open, because we know the current flows through an open circuit is 0. That's why you are making current source to be an open circuit, and voltage across the short circuit is 0. That's why in the previous case we have considered voltage source to be an short circuit. So this is a 4 ohm and 5 ohm, and we have another resistor here, the 2 ohm here, and plus minus this is 20 volt and this is a 2 ohm resistance. And connect the same load resistance here, your RL, and we are interested to find out what is this load current, which we have represented as what? IL double dash. So now you can use the concept which we know, the KCL, KVL, or a nodal method or a mesh method, to obtain what is IL double dash in presence of a 20 volt voltage source acting. So now you just look at this network, how you can simplify this part. So if I convert this a practical current source to an voltage, a practical voltage source, this is a practical voltage source. If I convert this into current source, if I convert this into a current source, so what is an equivalent network we get now? So here we have your load resistance, a 5 ohm resistance and a 4 ohm, and here we have your load value, and you know what is RL value is given in the question, it is 7.5 ohm, and your 2 ohm resistance here, and this if you convert, so you will get a 2 ohm parallel, and the current value is, it is 20 divided by this resistance value, it is 2, which is equal to, you will get a 10 ampere current. So this is the equivalent network when you convert this practical voltage source into a current source. So these are equivalent. So now you observe, to simplify this network, so we are interested in finding out what is IL double dash. So now look at these two resistors, they are in parallel. So if you simplify, you will get, the equivalent resistance is 1 ohm. Equivalent resistance is 1 ohm. So now if I rewrite the network, you will get, it is 5 ohm, and this is 4 ohm, and here you have your load resistance RL, and this resistance value is 1 ohm, and have a current source of 10 ampere. Current source of 10 ampere. So this is your IL double dash. So now again you convert this into a practical voltage source, this part. If I convert this into a practical voltage source, convert to voltage source. So what we'll get now? So you have 5 ohm resistance, 4 ohm resistance, and you have load value RL, and this is your I double dash, the I double dash. So what we'll get now? So a resistance of 1 ohm in series with your voltage source. What is the voltage source value you will get? It is 1 into 10 you will get, it's a 10 volt. That's a simplified network. So next you can just observe now, these two resistors are in series, a 4 ohm and a 1 ohm, they are in series. So resultant you will get, it is 5 ohm here. The resultant you will get 5 ohm. So if I write a new network here, so you have your 5 ohm resistance and a load resistance of RL, your RL and I double dash. So this is your 5 ohm, that's a 4 plus 1, 5 ohm. In the previous circuit you see it's 4 plus 1, 5 ohm in series with a 10 volt battery. So you get a 10 volt battery. So this is a network. So now we are interested in to find out what is I double dash here. So again you observe guys, so we have two nodes here. This is a node 1 and node 2. If I'll call this a node B, just find out what is VB, a node voltage VB here using a KCL, So if you know what is VB, you can write the I double dash, which is same as VB divided by RL. So using KCL, find out what is VB now, because the voltage across your load resistance will be same as your VB. So now apply KCL here, leaving currents, and the leaving current here. So what is the current flows through a 5 ohm resistance branch here? It is VB divided by 5, because the voltage across 5 ohm resistance is 5 here, plus the current flows through load resistance is VB divided by the load resistance value is given in the question, it is 7.5 ohm, plus the current flows through this branch is, now the potential at this end is VB. Again we have one more voltage source which is connected here, 10 volt. So minus to plus it is rise, again here plus to minus it is drop. So we can write it is VB, a rise in potential VB plus and a drop in potential minus 10 divided by a resistance along that path is, it is 5 ohm, which is equal to 0. So now you try to simplify this equation to know what is the unknown value Vb here. So phi inverse into Vb plus a 7.5 inverse into Vb plus a phi inverse into Vb minus 10. So if you simplify this, you will get, the value of Vb is, it is 3.75 volts, 3.75 volts. But I am interested in now finding out what is IL double dash. Now you substitute here, Vb we got it is 3.75 divided by the value of load resistance is 7.5, it is given in the question. So if you simplify, you get an answer a 0.5 ampere, 0.5 ampere, that is your I double dash. So now at the end, we need to summarize both the individual responses. So at the end, by SPT, when both the sources acting, the total response will be a algebraic sum of the individual responses. So you can write the load current which flows through a load resistance RL is your I dash plus I double dash. See, in the first case, when we obtain what is the load current value in the step 1, we got an answer of, it is the value which we got here, it is, you can see it is 2.5, a 2.5. In case 2, we got it is a 0.5 ampere. So it is 2.5 plus a 0.5. So you can write the value of IL is, it is 3 amperes. So that's a final answer for this question. Hope you understood this.